accessible at docs.iotex.io. In the IoTeX documentation portal, you have some introduction. There is the white paper that I highly invite you to read because it's like a wealth of information and knowledge about DePIN and like the state of the art of DePIN technology and architectures. And then we have some documentation about all the different infrastructures that IoTeX has built. So there is the layer 1 documentation. I'm not going through this one. As I said, I'm assuming you are a Web3 developer, so you're familiar with EVMs, Ethereum development, Solidity. Then there is the explanation of the IOID, which is our solution for decentralized identity management that allows a DePIN project to register device identities and owners on-chain and manage these operations both on-chain and off-chain. And then WebStream, here is where you find the documentation for WebStream. That's what we are going to focus on, right? This component here, which allows you to basically prove the physical work to your smart contract. So what you want to do usually is to, let's say, let's get started here. Yeah. So what you want to do is to build a sequencer, have a DA layer ready, and deploy some proving logic to this like infrastructure here. Now, to get started quickly, we provide a development environment where you can easily spin up a simple sequencer, a simple Postgres database to act as the data layer. It spins up like a single node web stream network, which is made of what we call a coordinator node and a prover node. And this allows you to send a test message, like let's say a simulated message as if it was a device message, to this sequencer and get out. After you send out enough messages to pack like a whole block of data messages, then you should be able to see WebStream fetching this data block and generate a proof according to your WebStream or your ZK logic. So it's pretty easy, actually. Let's actually go through this quick start. So I don't know if it's too small. Let's make it a bit bigger. Okay, so yeah, let's go through it. So first we create whatever folder for our project. I'm calling it WebStream. That could be probably the name of your project. We need to, so in this getting started, I'm not actually going through creating a ZK logic. Rather, I'm downloading a ready-made ZK logic that implements a simple range prover, which is basically proving that a certain number is within a certain range of numbers. So, and then later I'll show you how to get started creating your own logic. So to save our like WebStream logic, we need a folder, test project, okay. And we need to know what's the latest release for WebStream. So I have a simple command here that tells us, that just fetches from GitHub the latest WebStream release, and you can actually see it. It's 0.12. Okay, now that we know what's the latest release, we can fetch one of the 3 demo examples. I'm fetching the one that uses the RISC-0 like built example. So WebStream allows you to create your proving logic using different ZK frameworks. You can get started if you're not familiar with ZK, starting with a ZK virtual machine framework like RISC-0 is an excellent option because it allows you to create your logic using a standard programming language like Rust without caring about how to create an actual ZK circuit or all the complexities behind generating a ZK proof. So I'm downloading this example here. and it's inside the test project folder. That's the file with the example. Yeah, let's take a quick look at this actually, this example file by code test project 10,000. So that's the typical, I cannot move it. That's the typical project file for WebStream that contains your logic. This is like the binary code of your actual ZK logic. And it contains some settings like how this logic, what framework has been used to generate this logic, and where the ZK proof should be sent after the WebStream network has generated a proof, right? Where this proof should be sent. So in this case, I'm just leaving standard out so that we can see the proof generated in the console. So that's the, yeah, we have the source code for this range prover example on the WebStream repository on GitHub. Okay, now that I've downloaded the example, what I can do as a developer, I want to spin up the whole development setup, which is, where is it? Yeah, which is basically this setup here, right? I want to spin up a demo sequencer, a Postgres database, a single node WebStream prover to basically test my project. So what I do, I fetch a Docker Compose from our repository, right? So I have a Docker Compose here. If we take a quick look at this Docker Compose, just to confirm what it contains a few like images, like a sequencer, right? The coordinator node, some provers that implement the different like proving frameworks, and a Postgres database to serve as our like data layer. Okay, so I can just do like Docker compose up to start all these like services. Okay, so we see basically the log for all the different services, right? And the sequencer, the coordinator from WebStream, and yeah, the database and so on. So we have all the services ready for starting our development. I'll open another terminal, one more terminal. Okay, so basically I have the whole WebStream testnet running on my computer, plus I've started like a demo sequencer and demo data availability I can start from these ones to start developing my Deepin application, right? But I can start using them as a demo application to receive data messages and pack them, store them on the data layer, and then generate a proof. So I can focus on the WebStream proof development. Now, as I said, I'm not going through creating the prover. I'm using a prover that I have already downloaded, like the one that does the range proving. So what I can do, I can just send a test message to the sequencer. So this sequencer is configured to pack together one single message and pass it over to the WebStream network to basically prove that the data contained in the message respect the range prover algorithm. So let's actually take a quick look, right? Okay, so what I'm doing here, right? I'm sending this message, right, to my local host sequencer, to my sequencer running on the local host in the /message endpoint. That's the endpoint of the sequencer to receive data basically from the devices, the Deepin devices. So I'm simulating a Deepin device, sending the data. And the data for this demo is basically one input, which is an integer number, and a range. So two inputs separated by a comma that represent the range. And our prover will basically provide a proof if this first input is actually included in the range. So I'm sending out this message. And now basically you can see the log from the RISC-0 prover in WebStream that has started basically computing the data block. In this case, the data block is just one single message because that's how the sequencer is configured, to just pack together a single message and send it over to the WebStream prover. That's not ideal for scaling, but it's quick for development. So basically you see the ZK proof. That's a RISC-0 ZK proof generated by WebStream and visible on the console. That's because the demo project is configured to output the proof on the console, right? So one quick thing we can do here just to modify it a little bit, we can edit the configuration of the sequencer. So the sequencer, the starting command, we can add an additional parameter here called, we can call it aggregate. I'm not sure I remember it, but should be aggregation amount. And give this a value of, say, 3, right? Okay, hopefully I remember the correct parameter name. So this demo sequencer allows you to configure some parameters. Yeah, and one parameter is how many messages you want to pack together in a data block, which is the aggregation amount. So let me restart the whole like stack. Now, if I send a message to the sequencer, it should not do anything. Instead, it's doing it, and probably that was not the correct name. Let me quickly find it. Okay, that's, by the way, the repository for WebStream, where you also find the source code for the sequencer. There should be one setting that is aggregation amount. I was correct. Aggregation amount, which is default 1. Oh, I see the error. Okay. Usual live workshop issues. So I should have added the dash for the arguments. Okay, restarting services. I think it should be running ready. So let's send one message. Okay, so as you can see, the sequencer has received the first message, but because I've configured it to pack together 3 messages in a data block before sending it to the WebStream network, it's just waiting. So I can send one more message and a third one. Now that I send a third one, it will actually generate a WebStream task with 3 messages and send it to the WebStream prover. And then now WebStream is computing a proof for range proving over all 3 messages, and then generate a single proof for the entire block of 3 messages, proving that all 3 of them actually respect the fact that the input is within the range. So yeah, this was just to get you started on how you can, basically initiate the development of a Deepin project that it can provide verifiability in terms of the Deepin logic. Now, how would you, here is the proof, how would you like progress from here? The first thing would be to deploy actually your project to the WebStream testnet, right? Because we have been building it locally. And next, to configure your project to send the proof to your contract and then build your actual contract. So of course, we're not doing it now, but I just want to take you through where you can find these and just to get started. So basically, next step, would be you start building your proving logic, right? So in the documentation, you have like build the prover code, right? So how you actually generate a project file for WebStream. So assuming you want to build your demo using RISC-0, you can go here and see how, well, you should also be familiar with the actual RISC-0 development process, but it's everything linked here. So you can follow this simple guide to create your own WebStream logic. And then there are like the steps how you actually build your logic and generate the project file for WebStream that actually sends out the proof to an Ethereum smart contract. And finally, how you deploy this logic to the actual like public testnet for WebStream. And then next step would be you start building your on-chain contract that actually receive this proof, verifies it, and sends incentives out. So before I stop here, just want to point you to like this building Deepins under the builders part of the documentation. Here we are going to publish an end-to-end DeWi demo. It's still in progress, so I would like to invite you actually to register to our newsletter. I'm going to show you where, because we will notify you when this is ready. But basically, this one is taking you step by step into creating an end-to-end working decentralized Wi-Fi network, physical network, even using real devices to act as Wi-Fi access points. This is already built, but it has to be updated to the latest version of WebStream. So I would really love if you guys register to our newsletter. If you go to the Deepin incentives contract, you can see an example how a smart contract would actually receive a proof in this function, would receive the actual proof from WebStream in the data field, decode it, and then distribute rewards based on the output. Not going into the details because it's really, even though if it's a proof of concept, it's anyway a little bit complicated to explain in short. Actually, a good idea is to go to our, let me move, to go to our developer portal, developers.iotex.io, and subscribe to our newsletter here, and you'll get notified when the end-to-end demo is ready. And here you can also quickly get started with setting up a MetaMask, getting IoTeX test tokens, and start building something or experimenting, at least with our layer 1. I'm stopping here because there is a lot, of course, to say, but would require a few days workshop. So passing over to Giuseppe again. Let me.
Yes. let's see, maybe I can share this slide real quick, Simone, just with the main resources. So you guys can check them out, and maybe Tracy, if you feel like sharing these.
Yes, okay.
Sweet. So I think you guys can see my screen now, right?
Yes.
Yeah, so the main resources, like Simone was saying, is the docs. That's your best friend, is docs.iotex.io. If you want to meet other developers or also, be part of our community, I think our community is doing an amazing job. And you can check out iotex.io/discord. And Simone was just sharing the developers portal, which has some, pretty quick, immediate tools to get developing, setting up MetaMask, getting test tokens, etc. And subscribing to the newsletter, and that is developers.iotex.io. And yeah, I think with these three, you're basically in great shape. And you can always reach out to either myself or Simone on Telegram or on X. And we're always happy to help.
Okay, good. So we'll just jump into the Q&A session. Actually, at the end, like you have already covered one question. So there have another two. The first question is asking like, how does IoTeX process and optimize the interaction between on-chain and off-chain data?
Yeah, I think that's more or less what we have been showing today in terms of architecture. So let's maybe clarify it a little bit better since, yeah, someone is asking. So basically the main problem between connecting on-chain and off-chain data, the main problems are a few. One is that on the opposite of what you would think, a device in a Deepin project is never going to send data directly to the smart contract, right? If you had one simple use case would be where the device has some sort of trusted identity that the smart contract can trust. We have some use examples. For example, Pebble Tracker is a device that we created to prove this type of simple Deepin schema, right? Where the device has a trusted hardware identity that it's used to find the data message. And then this data message could be sent directly to a smart contract. The smart contract could verify the signature of the device, so trust the device that's sending that data and then do something with that data. The problem is that DePINs are basically IoT systems, right? So they are fundamentally like they feature a huge amount of data volume and a huge number of devices and a huge number of applications. Multiply all of these and you can easily understand that a blockchain cannot manage data incoming directly from devices. It would be too costly, impossible to store this data, impossible to process this data, and yeah, it's just not doable. So you need to understand how you can make a smart contract do something based on what devices are doing in the physical world, but still trusting what's the information is without the device talking directly to the contract. And also how you scale all this communication. And yeah, if you want, also how you make it private. That's another problem. Where you store all this data. And that's where all these like layers, how we decompose, why we decomposed everything into layers, and each layer should be decentralized and should provide one specific service to a Deepin application. If these layers are decentralized, and some can provide privacy, some can provide data storage, some can provide data processing, then the whole Deepin application can be trusted. So yeah, how we manage it, there is no like silver bullet to find a solution, how you solve the deepin problem, but for sure, we are providing like state-of-the-art infrastructure and protocols. We have not talked about IOID, for example, that solves the identity lifecycle in Deepin. There are for sure many problems. We are trying to provide, like top-notch infrastructure and protocols to help Deepins to like at least start from something that is proven to work and to be secure, and then keep building on it.
Nice. Then last question. How does IoTeX ensure compatibility with different IoT devices while maintaining decentralization? Like, do you provide like any specific guidance or standards for device manufacturers and developers?
Yeah, that's actually a very good question. So while we are providing decentralized protocols, so we don't focus on devices specifically, we contribute a lot of research on the hardware side. This research spans from how to design an IoT device that is Web3 ready using, for example, TEs on devices. And this is all the Pebble Tracker side of our research. If you're interested, you can look into the Pebble Tracker documentation. Up to we are building what we call IO Connect, which is an abstraction layer for hardware. It's basically a library that allows to like provide a layer that is common to many different IoT platforms to provide all those features that are needed to Web3 devices, ready devices. For example, some cryptographic primitives, some decentralized identity features, some communication feature, all these like features that are the foundation for a firmware that is intended to interact somehow or to produce data that serves a blockchain application. All these like fundamental features, we have hacked them into a layer that we call IO Connect. And this is basically a library that at this moment supports ESP32, Linux embedded systems, Nordic Semiconductor. We have a demo, and basically it's the foundation for like firmwares that want to like talk to Web3 applications and trying to abstract away the hardware layer from these firmwares. So this is one way we facilitate IoT manufacturers to create devices that are Web3 ready in a way that is portable and more like hardware transparent. Of course, it's still early development, but it's available. There are demos that show how you can create a firmware that, for example, implements device registration into our IoID infrastructure and how to use it to authenticate the device with its decentralized identifier with a server where it's sending the data. So there is a lot of development and research on this side. Again, no final solution, of course, but definitely we are contributing a lot. And well, actually, I'm taking the opportunity to share this latest, or is it? Is there a way we can share something maybe after? Is there a group somewhere?
I just dropped the link to IO Connect in the chat here. I don't know if like everybody can see it, but maybe Tracy, you can help out.
I wanted to share the latest research paper that I've not even read yet, but I was about to. It was released, I think, yesterday. The title is Towards Credential-Based Device Registration in the Apps for Deepins, which is another like article that we have released about the device side of Deepin, where we are researching how you can implement device registration for Deepin applications specifically. So it talks about basically using ZK proofs and DIDs on devices to make them more Web3 ready. Maybe
I dropped it in the chat. Okay, so I don't know if Trace, you have a way of like highlighting it on YouTube for everybody who's watching, or
Yeah, I can just copy paste and drop it.
Yeah,
in the
exactly.
commenter. Yeah.
Sweet. And then I can maybe add the other links too, right? The Discord, the docs, and the portal.
Perfect. Yeah. So for now, I don't see any new questions coming.
Yeah.
So I guess,
But if you have, you
yeah,
can always share in the chat, and then we'll go through them. Maybe it's a good excuse to post something on
Yeah.
X for everybody to read.
Okay. And yeah, thanks for the answers, Giuseppe and Simone. And today's, I guess, TinTinLand meeting, technical sharing session has come to an end. And thank you to the guests and all the audience for your active participation. I'll see you next time. Bye bye.
Thank you.
Thank you. Bye-bye.
Thank you. Bye bye.